There are two types of condensation polymers. One is polyester, the other is polyamide. Let's take a look at polyester first. In the formation of polyester, we typically use a carboxylic acid or an acid chloride to react with an alcohol, in the process forming an ester linkage. And the byproduct water is being produced, unlike in the case of the formation of addition polymers. One polyester that you need to know is when benzene 1,4-dicarboxylic acid react with ethane 1,2-diol. So this is your benzene 1,4-dicarboxylic acid. When reacted with ethane 1,2-diol, it will form a polyester, acronym PET. And do know that N molecules of each, when reacted, will give a byproduct of 2N-1 water molecules, since one of the H here and the OH here remains as part of the polymeric chain. It is important to note that PET easily hydrolyzes in acidic or alkaline medium, and hence cannot be used to make containers used for storage of acidic or alkaline chemicals. Polyamides. In the formation of polyamides, we will use a carboxylic acid or an acid chloride, which we'll see later in the example, reacting with an amine. This is the amide linkage that's formed. In the process, a byproduct again is produced, which is a water molecule, unlike that of your addition polymers. In the formation of another type of nylon, we can use this diamine to react with this acid chloride. In this case, the byproduct will now be HCl, and the polymer form will be called polyamide since it will contain amide linkages. And again, if we were to use N molecules, let's now take a look at the reason why polyamides are more prone to creasing. The reason is because if you now take a look at amide linkage, you will know that amide linkage can easily form hydrogen bonding with water molecules, either via the carbonyl group or otherwise via the NH group. Because of this, polyamides will allow water molecules to penetrate the areas between the polymeric chain, permitting the formation of new hydrogen bonds as drawn here, and the new shape will becomes locked in. The new shape becomes locked in as water evaporates, and that's how creases are formed. However, polyesters are known to be wrinkle-free. The reason is cross-linking occurs between polyester polymeric chain when permanent dipole to permanent dipole attraction forces are formed. This enables the cross-linked polymeric chain to be water resistant, as the non-polar groups are exposed to the water molecules. Hence, polyesters are wrinkle-free. In the case of both polyester and polyamides, both the presence of ester linkage and amide linkage makes polyester and polyamides vulnerable to hydrolysis. So in the presence of acidic or alkaline medium, the covalent bonds in the polymeric chain will break. And hence polyesters are biodegradable. Similarly, polyamides are also biodegradable. Finally, a summary on the comparison between addition polymerization and condensation polymerization. The monomer used in addition polymers is alkene, C to C double bond, while condensation polymerization requires the use of alcohol with carboxylic acid or acid chloride to form ester. In the formation of amide, amine will react with carboxylic acid or acid chloride. The linkage in the polymeric chain is primarily C to C single covalent bond, while in the case of condensation polymers is either amide or ester linkage. Addition polymeric chain is unreactive, saturated, and inert, while condensation polymeric chain is reactive as it contains positively induced carbon atom in carbonyl group. Addition polymers can be disposed by burning since they are non-biodegradable. Condensation polymers undertake chemical reactions like hydrolysis, and hence they are biodegradable. Addition polymers cannot undertake hydrolysis reaction, while condensation polymers are able to do that. In the formations of addition polymers, there are no byproducts that's formed. In the formation of condensation polymers, byproduct with smaller molecules like water or HCl are formed. The type of growth in additional polymers is known as chain growth, while in condensation polymers, they grow by step growth. Additional polymerization is initiated using free radical, while in condensation polymers is initiated using nucleophile. The mechanism for addition polymerization is addition, while in condensation polymerization is substitution.